Okay, hi everyone. I'm going to look at question 5 and 6 briefly. This is still in exercise 2A, sorry, 7A. Now you probably haven't seen this symbol before for subset. Sorry, I didn't mean to do that. Here, apologies, subset, that symbol, okay? So this statements they're making that they're saying, well, if set A is this, is it a subset of set B, right? So subset. Okay, in the first question, it's a bit odd really. They're saying, is the set of A, this is the symbol for an empty set, right? So does an empty set, could you write that as a subset of set B? And the answer is yes, you could. The next one's probably a better question. Set A includes the integers 2, 5, 8 and 9. Is that a subset of set B? The answer is no, it's not. And in fact, it's the other way around. Set B is a subset of set A. Let's try and draw a Venn diagram of this. I could show set A as a big circle. There's set A. Inside of that, I could have a set B. Set B includes the numbers 8 and 9. Set A includes those, but it also includes a 2 and a 5. All right. So B is a subset of A. A is not a subset of B. Right, let's move on. Third one. Set A. All right, we've got real numbers and they lie between 2 and 3, including the 2 and the 3. Set B is the set of all real numbers. So set A definitely is a subset of set B if it includes all real numbers. Okay. D. So now we've got this set A, okay, it's rational numbers, and they lie between 3 and 9. Over here, set B is real numbers, and they're lying between 0 and 10. So this is a yes. And a reminder, what's a rational number? So the symbol Q, when you write it by hand, maybe just put one line through the Q like that. Or you can try and copy the way they do the Q. Rational numbers. What does it mean? Numbers that you can write as a fraction or as a ratio. Okay. Real numbers includes rational numbers. And the range they had here from 0 to 10 was bigger than the 3 to the 9. Perhaps I should be using the word domain there if we think of graphing. Anywho, what's next? Set A. We've got integers, right? That's like whole numbers, but including negatives and 0. And it lies between minus 10 and 10. Does that belong to this set of integers lying between 0 and 5? But we've got different elements here. Here they're calling the elements x's. Here they're calling them z's. It's like trying to compare apples with bananas. So that's out. Same as in the next question, they've got the set of x values. Here they've got the set of y values. But you could also think about these intervals. So for this last question, we've got x values lie between 0 and 1, inclusive. Here, these y values, they go from 0 to 2, but they don't include the 0. So even if these were x's, imagine these are x's, I would still say no, because set B does not include 0, whereas set A did include 0. Okay? So let's move on to question 6. All right, this is a shorthand notation that you can use for real numbers. So when, for example, if you have a set with elements x and the x values belong to, this funny looking E means belong to, the set of real numbers, okay? Then you can just go to this shorthand approach. Your book explains what's happening, but basically, if you've got square brackets, we are including that lower value. Right, so this is telling me here for 6a that we are including the 2, but we would not be including the 5. So if I was to write this out using the regular set notation or interval notation, I could say I've got the set of elements, which I'm going to call x, such that x lies between 2 and 5. Now it includes the 2 but not the 5. Right? Where x belongs to the set of real numbers, like that. Okay, so hopefully that made sense. So in my mind, this is just a shorthand way of writing this out here, because this can be a bit long-winded, but we're generally only going to use that shorthand if we're dealing with all real numbers. Okay. Final thing, if I can just get down the page slightly here. This question 7 here is looking at rational numbers. Here we can say, so I'm not doing these questions, I'm just talking about the notation. We've got rational numbers here with a little plus next to it. That means we're only interested in the positive values, right? And if we put the little 0 there, we're including the 0. That little 0 can be quite useful if I'm looking at natural numbers, because technically natural numbers don't include 0. It's my symbol for natural. It's like our counting numbers, natural. So they start at 1. It's like I'm counting up whatever I'm counting, alpacas. But if I can include the 0 in that set of numbers, if I just write a little 0 there as a subscript. Notice that the plus for positive is a superscript. If I wanted to show negatives, for example, we're doing that as a superscript up here. If we want to show that we're including a 0 down there. Okay, thank you. Please learn this notation because it's quite useful in a range of different topics, especially when you're looking at functions and graphs.